Okay, this is part 2 of our test review for pre-algebra. In this section, it starts off telling us to evaluate each expression, so we will find an answer for these, and we need to show all of our work. So on 31, we are trying to find the square root of 6 plus 75. Now, since 6 plus 75 is in parentheses, we have to solve that first. So 6 plus 75 is 81. So now we're finding the square root of 81. And 81 is a perfect square, so we know our answer is a positive 9. Now, while we can find two different roots for the square root of 81, since we are evaluating expressions, we are always using the principal square root, that positive square root of our number. So we'll only have to list positive 9 for number 31. Now number 32, 33, and 34, they're all the same. We have to evaluate each expression. So we first use our order of operations. So I'm going to write PEMDAS up here just for reference. So first we need to do the parentheses. 2 times the square root of 225, since that is a perfect square, it's positive 15. We always use the principal square root, minus 160. So 2 times 15 is 30 minus 160. In this case, we have a negative 130 for our final answer there. Number 33 is a fraction, so we're taking the square root of 144 first. That is 12 over 24, which we can reduce by dividing both sides, or numerator and denominator, by 12. And we get 1/2. So 1/2 is our final answer there. That was a quick one. And for 34, now this negative sign is on the outside of our parentheses, so we apply that at the very end once we're done with this inside expression. So the square root of 121 and the square root of 289 are both perfect squares. So this is 11 minus the square root of 289, which is 17. That negative sign out there. Okay, I'm going to carry that back down. 11 minus 17 with our integer rules is a negative 6. So we want the opposite of negative 6, which is just positive 6. So our answer is positive 6 for that one. Now our second section here on this page is saying find the two integers. Now we're finding integers. Each square root falls between. So our first step is to find the two square roots, one lower and one bigger than the square root given, and then we find the square root of those two perfect squares. So the square root of 123, the lower perfect square is the square root of 121, and the square root of 144 is the bigger perfect square. So the two integers that this number falls between, the square root of 123 is 11 and 12. So this would be our final answer, 11 and 12. Because we want integers, we don't want the perfect squares, so we have to go that extra step and actually find the square root of both of those perfect squares. So for 36, the square root that is smaller than the square root of 54 is 49. It's a perfect square. And the perfect square root that is bigger than the square root of 54 is 64. So the square root of 49 is 7, and the square root of 64 is 8. So the square root of 54, whatever that number is, falls between the two integers 7 and 8. So that is our final answer there. Now we get to real numbers, and this is when we're classifying numbers. So we're looking at 37, 38, and we need to write all the names that apply to each number. So that's real numbers, irrational numbers, rational numbers, all of those, all the way down to whole numbers. So the square root of 81 is actually a perfect square, so we can evaluate that first, which is the positive 9. Now that is a real number, so we're going to list that. Now we have to determine if it's rational or irrational. Since it's a whole number, or a number that doesn't have any decimals, or we can express it as a fraction, 9 over 1. This is a rational number. It is also an integer. And since it is positive, it's a whole number as well. So it's actually all 4 categories. Now the square root of 7. We can find the square root of 7, so that's how we know it is a real number. The only time it would be not a real number is if it's the square root of a negative number or zeros in the denominator. And since the square root of 7 is not a perfect square, it's an irrational number. And once we determine it's an irrational number, we can't get any more specific than that, so we are done with that section. Now the next section is just like we had on our homework. We have to determine whether the number is rational, irrational, or not a real number. So we're only choosing one of these, and that's the only thing we have to list. So the square root of 16 is actually 4. That is a perfect square. So this is a rational number. We can express that as a fraction. For 40, it is the square root of negative 16 over 49. This negative sign that is underneath the square root tells us that this is not a real number. We cannot take the square root of a real number, or of a negative number, excuse me. A real number. For 41, we're trying to find the square root of 100, and we apply this negative sign after we've found the square root, since it is on the outside of our square root sign. So it's actually negative 10. So that is a rational number. Now we could get more specific and say it's an integer, but in this case we're only listing whether it's rational, irrational, or not a real number. Now the square root of 38 is an irrational number, and we know that because it is not a perfect square. So if we found the square root of that with our calculator, the calculator would round it so it would look like it was ending, but since it's not perfect, not a perfect square, it ends up being irrational. Now the last section on our review is the Pythagorean theorem section. We have both just solving one side of a triangle and the word problems that apply to both Pythagorean theorem. So the first section is just we're given A, B, and C. Solve for the unknown side of each right triangle. Since this is a right triangle, we know that we can use the Pythagorean theorem. We have to make sure we write out the formula that we use and show all of our work. So we want to use the formula, show that formula, and show all of our work. So we're drawing a picture. Always draw a picture when you're given information. And we know it's a right triangle, that's why I put the right triangle sign. So A, we don't know, so I'm just going to pick that side, that leg to be A. B is 16, and C is 20. So our formula, A squared plus B squared equals C squared, should be committed to memory by now since we've worked with it for a few days. So we don't know A, so we're keeping that A squared plus 16 squared equals 20 squared. Now again, we still don't know A squared, bring that down. Square root of 16 is 256. And the square root of 16 squared is 256, and 20 squared is 400. So then we subtract 256 from both sides, so it's just like we're solving an equation. So A squared equals 144. Now to find the length of A, we need to find the square root. So A is 12. And we have to make sure we use our labels. So in this case it's inches, so A equals 12 inches. 144 is a perfect square, so we know that's 12. Again with 44, draw a picture. Always start with a picture. We know A to be 6 feet, B to be 8 feet, and we don't know C. So again, write A squared plus B squared equals C squared. That is the formula we're going to be using here. A is 6, so we're going to square 6 plus 8 squared equals C squared. 6 squared is 36, and 8 squared is 64 equals C squared. That is 100 equals C squared. Again, take the square root of both sides, and 10 feet equals C. So that is our answer, 10 feet there. Now we get into word problems. So we're using the same formula, but in this case we have word problems. Well, the first one says, for high school wrestling competitions, the wrestling mat must be a square with an area of 361 square feet. What is the length of each side of the wrestling mat? So in this case, we're going to draw a square. So this one, we are not using Pythagorean theorem. It's just like some of the problems in our books and our bookwork that we've done. So this square mat has an area of 361 square feet. Now we want to find the length of each side, okay? So each side, we're going to name that S, and since we know it's a square, we know each side is equal. So to find the length of one side, we need to find the square root of 361. We know S squared equals 361, since if we were to find the area of a square and each was called s. Each length was called s. We'd call s times s, which would be just s squared. So to find just the length of one s, we find the square root. And in this case, s equals 19. Since this is a word problem, we want it to be written in a complete sentence. So we could write each side of the mat is 19 feet long. That would be our final answer there. For 46, Matt ran 9 miles due north and Allie ran 12 miles due west. How far apart are Allie and Matt at the end of their runs? Now this sounds like a Pythagorean theorem problem, so we're going to draw a picture. So Matt went due north. Sorry, that's not a straight line. Tried as best as I could, so just act like that's straight. Going due north. Allie ran 12 miles due west. On the west. Matt ran 9, Allie ran 12. Now we want to find out how far apart they are. So we want this side right here. Now we know this is going to be a right triangle, so we're going to use a squared plus b squared equals c squared. Now a and b are this 9 and 12. It doesn't matter which one you choose for a and which one you choose for b, so I'm just going to write 9 squared plus 12 squared equals c squared. 81 plus 144 equals c squared. 81 plus 144 is 225 equals c squared. So we find the square root of both sides. C equals 15. So then again, since it is a word problem, we're going to write it in complete sentences. So Allie and Matt are 15 miles apart. And then we are done with that problem. Let's see, last but not least, we have an extended response problem. So this is when we're going to write in complete sentences. It says, explain the rules for multiplying powers with the same bases and dividing powers with the same bases. We want to use complete sentences to explain our answer. So first I'm going to talk about multiplying powers. So when multiplying powers, with the same base, we add the exponents together. And I'm going to put an example here. AX times AY equals AX plus Y. Just so I make sure I am clear on my explanation. Now when dividing, powers with the same base, we subtract the exponents. Okay? And again, I'm going to put an example here. AX divided by AY equals AX minus Y. So those are complete sentences. I included an example, which on your test, something will be like that on there. So I would use examples if you feel you need those to be more clear. This wraps up our video. Hopefully you guys did really well on your review guide. Our test will be on Monday, so come with any questions you may have over this guide. If you're still unsure on certain things, we can go over it before our test. So, good luck, guys.